If we were going to talk for a few minutes about the requirements, again, this kind of follows from the last slide in that Boeing identified a large group of people with much at stake. So those airlines, they have to turn a profit if they're going to stay in business, and so they're very concerned with their equipment. That's the heart of their business, is to have airplanes that turn a profit for them. So that's where the requirements were driven from for the Boeing 777. Okay. By the fact that Boeing went out and consulted all these people, it's likely that they got better, more accurate requirements for the airplane as a result of this effort. Of course, Boeing has to look at all of those requirements and trade off and make sure that each requirement is justified from a business perspective. The fact that a stewardess wants a lavatory personal for herself and her crew may be great for the stewardess or the airline attendant, but that may not fit into the scope of the real goal of the airlines that say, you know, we have to turn a profit with this airplane. So the requirements are always balanced against each other to make sure it's justified. Just a very quick example, Boeing went to great lengths to establish what the requirements for a cargo loading and unloading system were to be. This resulted in some design of some very nifty containers that are loaded on the ground with baggage. They're then hoisted up, put in the cargo hold. There's a roller system in the cargo hold that allows one person to maneuver that container around and place it, and so very quickly and easily they can load and unload all of the baggage in a Boeing 777 that had not been done before. And that was the result of that discovery of requirements by many stakeholders, including cargo loaders. The Air Force, the way they handle requirements is the Air Force decision makers get together. They probably have some consultants, but they come up with a request for proposal. Here's what we want in a new airplane. Who wants to bid on this? And they put that out for bid, and the few prime contractors in the world that can compete, they bid for it and try to get the contract. It really boils down to a wish list for Air Force generals because they have these capabilities, these military capabilities that they want, and that's where that set of requirements comes from. The set that happened for the C-17 were based on previous research airplanes. They had these, in the 70s, these research airplanes that established some capabilities in terms of takeoff and landings from unimproved strips and maneuverability requirements and things like that. So that was part of the process to come up with the request for proposal. They made it a point that we're only going to use off-the-shelf technologies. We're not going to develop all these technologies ourselves. So in their mind, that was a way to save money and time, was to use commercial off-the-shelf technologies and integrate those into this military system we're building. A little commentary here is I really feel like they had kind of a lack of effort and importance placed on true requirements discovery from many of the users of the system. They were really focused on the capabilities from a military standpoint. They really didn't allow McDonnell Douglas to go off and investigate all the users and what the real requirements are. And so an example of that is kind of how the payload for the C-17 evolved over time. It changed at least 5 times over the development life. It was initially set at 130,000 pounds. McDonnell Douglas took a look at the requirements and said, oh yeah, well we can do it at 172,000 pounds. How would you like that? The military said, yeah, we love it. Go forward. But then they found out later on, down the road, that this had an effect on many other aspects of the airplane that drove up not only the size of the airplane, of course, but also the price. So then the DoD backtracked and said, you know what, really, we only need something with 167,000 pounds of cargo capacity. But later on, when they got to the cargo loading system, well, that was an additional 5,000 pounds they didn't count on. So now they had to roll back to 160,000. And each time they changed the payload, that changed many other things, including the structures of the wing, for example. Well, then the military said, well, you know what, now we need to have a 3,200 mile range. And again, this is probably the generals that rotate in. These requirements are changing. That makes it very difficult to design an airplane and you go along a development path and all of a sudden they change a fundamental requirement like range on you. So when they implemented that 3,200 mile range, they had to redesign the airplane. So then the weight shifted again back to 110,000 pounds. And this debate went on what the cargo capacity. It lasted more than 10 years. All the while, McDonnell Douglas is having to change the design in order to accommodate those requirements for the cargo capacity. So that gives you an idea of why this program ended up taking so long, because things like these payload requirements were constantly changing. So the schedule. So Boeing, I'm sure, did some work in the 80s, but they said basically in 1990 we're going to start this program, and they delivered the first airplane to United Airlines in 1995. So we could call that a 5-year development effort. Of course, they did have some technology problems or issues along the way. This was the first fly-by-wire airplane they had, which removes physical linkages between the control yoke and the control surfaces. The signals go through a computer then activates actuators. So they had some issues with fly-by-wire because it was a new technology. They had some challenges with the ETOPS. That stands for Extended Range Twin Engine Operation. It has to do with the fact that intercontinental planes always before had more than 2 engines, 3 or more. The first time they went to 2 engines, the FAA had special requirements they had to meet for twin engine operations over long distances. So they had to work through those issues, which required more testing and whatnot. Also, this was an all digitally designed airplane for the first time. CATIA was the CAD tool they used to do this, and they had some issues with the software CATIA that they had to work through. But when they had these issues, the response to that was, okay, we're going to absolutely keep the deadline. We're going to meet that 5-year development time, but we're going to open the checkbook, and if it costs more to put more resources on this, to do more testing, to spend more on it, we're going to do that. So the way they responded to the issues was they opened the checkbook and pushed hard to meet the deadlines. The way the C-17 went was they started pre-1980s doing some of the research on the technology of the C-17, and they delivered their first airplane operationally in 1994. So we might call that a 14-year plus development schedule. They had some technology issues, and some of them were kind of similar to the ones Boeing had. They had a lot of trouble with the off-the-shelf technologies and integrating those into a military environment. So they struggled a lot with using off-the-shelf technologies. They had some similar fly-by-wire instability problems as the 777, so they had to deal with those. They had some issues with the composite structures that they were using and the fact that the fuel tanks leaked because they weren't able to seal and fasten the composite panels and components together like they thought they would, so they had to work through those. They actually had a wing structure failure. They did the investigation and found out that the initial analysis by the engineers had a math error in it, so they had to go back, redesign, and retest to fix those errors that they found through the development. And the way that McDonnell Douglas and really the government responded to these issues, because they weren't meeting the deadlines on time and on budget, the way the government handled it and Congress handled it was they said, you know what, we're going to reduce the funding and we're going to increase the deadline. So they said, they kind of had the opposite response to Boeing when they had issue is the Department of Defense said, actually it was Congress that said, well, we're going to prolong this development effort and we're going to reduce the funding along the way. The oversight. So Boeing has a long history of airplane development efforts, so they had some history and their previous process to fall back on. They put a lot of effort into identifying the right requirements, and then once they had those, they marched forward with those. They were very conservative in the decisions to put new technologies on board. They struggled a lot with the fact that that fly-by-wire was a very different approach to airplanes that they had not done before. It took a lot of justification before they let that technology on board. And I'll say here that while outsourcing was used, so somewhere between 30 and 50% of the Boeing 777 is manufactured outside of Boeing, they still maintained control of the overall development effort and the integration there on site in Everett, so that they had control of the decisions themselves. They weren't at the mercy of someone external. So the oversight comes from Boeing's long history of developing airplanes and kind of knowing the right aspects of systems engineering competencies to use in the development effort. For the C-17, on the other hand, McDonnell Douglas was an experienced and successful contractor that had a long history of both military and commercial airplane development. They were somewhat restricted in the discovery and management of requirements, so the government program didn't allow them to go out and investigate and really identify what the requirements were. They were kind of stuck with what was handed to them, and so they were doing the best they could with what they were handed. They were forced to use off-the-shelf technology, which was unproven in the military world, and so those caused a lot of issues. And the fact that those off-the-shelf technologies were pushed on them, they weren't given a choice on using those or not. They were told you're going to integrate those. That caused some problems. McDonnell Douglas operated in this environment of continuous audit and oversight and investigation by Congress and the government entities. That's the way government acquisition works, is the government has total control over the budgets and how things are documented and what has to be looked at by many people and approved up a chain of hierarchy. So it's a very rigorous audit-based oversight process. And so what that resulted is decisions were often made externally to McDonnell Douglas. They didn't have full control of their development decisions and design decisions and lots of the funding. So when things went bad, they couldn't open the checkbook and say, let's fix them and let's fix them now. They had to go to Congress and justify it. And Congress, kind of set the spending limits and said, we're going to push this. If you can't get it done for this price at this time, then we're going to push the schedule.